Hey everyone, today we're going to talk about a piece of software that honestly has probably shaped almost everything you see around you. Every building, every machine, every single product you've ever touched. We're talking about AutoCAD, and we're going from a completely blank canvas all the way to a 3D world. Let's get into it.
So let me ask you something. How do you design, say, a super complex machine with perfect, down to the millimeter precision when you're starting with absolutely nothing? I mean, really think about it. Every single little part in a skyscraper or a jet engine has to fit together perfectly. So how do you take an idea from your head and turn it into a flawless blueprint for the real world? Well, the answer isn't just about drawing, it's about defining an entire world with mathematical perfection.
So, first things first, what exactly is AutoCAD? Well, at its core, you can think of it as the modern version of an old-school drafting board, but, with superpowers. It's basically where ideas get their first, super precise digital shape.
Okay, so the official definition is that it's a computer-aided design, or CAD software. Millions of people use it to create these incredibly precise 2D and 3D drawings. But here's what that really means. Every single line you draw isn't just a mark on a screen, like in a painting program. No, it's a piece of data. It has a specific length, a specific angle, a specific location in space. And that, right there, that's the huge difference between just drawing on a computer and true computer-aided design.
And listen, this isn't some tiny, niche tool for a few experts. For decades, this has been the gold standard. Architects, engineers, designers, they all use it. I mean, it's a safe bet that if something was built in the modern world, AutoCAD was probably its first language. So when you learn it, you're not just learning software, you're basically learning how our world is actually put together.
All right, let's get into the nitty-gritty. Everything, and I mean everything, starts in 2 dimensions. Before you can ever build up, you gotta lay it all out flat first. This is the foundation. This is the digital blueprint.
And the process for 2D design, it's actually pretty straightforward. It always starts with the basics. First, you have to set your units. You're basically establishing the rules of your little universe, the scale. Next, you draw your basic shapes. This is like your raw material. And only then do you start modifying and refining. Kind of like sculpting that raw material into something way more complex. It's a really disciplined way of working that makes sure everything is precise right from the very beginning.
Now, I know this looks super basic, right? Lines, circles, arcs, rectangles. But honestly, this is the entire vocabulary of 2D design. Think about the most complicated blueprint you can imagine. I promise you, it's just a really clever combination of these simple shapes, all drawn with perfect mathematical accuracy. These are the fundamental building blocks of, well, everything you create.
Okay, so if lines and circles are the words, the vocabulary, then tools like trim and offset are the grammar. They're what let you connect, cut, and arrange those basic shapes to make a coherent, precise sentence, or in our case, a really detailed technical drawing. This is exactly how you get from a bunch of simple shapes to a complex professional blueprint.
All right, so we've got our flat blueprint all laid out, but how does it actually leap off the page and become real? This next step, going from 2D to 3D, is honestly where the magic happens. It's the huge leap in modern design where a simple drawing starts to become a real virtual object.
And you know what? It all starts with something incredibly simple, a 2D profile. Yeah, just a flat cross-section of the thing you want to make. Right now, looking at it, it's just a bunch of lines. But don't be fooled. This simple shape, it holds the essential DNA for the entire 3D object we're about to create.
So, how do we make that leap from flat to solid? Well, we use powerful commands, and one of the coolest is called revolve. Just imagine taking that flat 2D shape we just looked at, putting it on a virtual potter's wheel, and then spinning it a full 360 degrees. What do you think you'd get?
Boom! You get a perfectly formed 3D solid. Just like that. That one single 2D profile, spun around an axis, instantly creates a complete virtual object. I mean, that's the incredible power of CAD, right? Taking one simple instruction and turning it into a complex 3D form.
Okay, so creating shapes is one thing, but managing all that complexity, that's what separates the amateurs from the pros. And AutoCAD is packed with these incredibly smart features, power tools really, that let you work super efficiently, even on the most ridiculously detailed projects. Let's take layers, for example. I want you to imagine you're drawing a floor plan, but on a stack of clear, transparent sheets. You'd draw the walls on one sheet, right? Then you'd put the electrical wiring on another sheet on top of that, and the furniture on a third. Well, layers are just the digital version of that. They let you organize your drawing so you can turn different parts of it on or off.
That way, you can just focus on one thing at a time without getting overwhelmed. It's just organizational genius.
And then there are blocks. Seriously, just think of them as digital Legos. Let's say you need to use the same object over and over and over again, like a specific type of door, or a window, or a screw. You can just save it as a block. This saves you a ridiculous amount of time for one, but it also makes sure every single one is perfectly consistent. But here's the best part. This is the real game changer. If you need to change that screw, you just update the original block and bam, every single copy of it in your entire drawing updates automatically. How cool is that?
Okay, so we've talked about the basic vocabulary, the grammar that puts it all together, and the power tools that make it efficient. Now let's put it all together and see how it works in a real project, from start to finish. We're going to look at how you'd build a mechanical screw jack.
You know, the actual design workflow is a lot like how you'd build something in the real world. You don't just make a whole machine at once, right? No way. First, you create the 2D blueprint for every single individual part. Then, you use tools like that revolve command we talked about to model each of those parts in 3D. And then, for the final step, you bring all those virtual parts together into a digital assembly. And this is so important because you can test how everything fits and works before a single piece of real metal is ever cut.
And this right here is the payoff. Every single one of those components, each one starting its life as just a simple 2D line, is now a 3D object, and they all fit together into a perfect, functional digital prototype. You have to remember, this isn't just a pretty picture. It's a virtual machine. It's the culmination of every single tool and technique we've just talked about.
So, there you have it. We went from a single line on a blank screen all the way to a functioning 3D assembly. AutoCAD gives you the tools to literally build reality with absolute precision. Really, the only limit is what you can imagine. So the question isn't what can be designed anymore. The real question is, what are you going to design next?